Here the problem is find Fourier series of f of x equal to mod sin x in the interval minus pi to pi. They asked to find Fourier series to mod sin x in the interval minus pi to pi. So in the previous sessions we determined the three Fourier quotients a0, an and bn. But here the interval is minus pi to pi. If you observe the interval as minus pi to pi, check whether the given function is even or odd. We know sin x is odd function, but mod sin x is an even function. Since f of x is an even function defined in the interval minus pi to pi, its Fourier series contains a0 and an terms. So Fourier expansion is f of x equal to a0 by 2 plus sigma an cos nx. To find a0, formula given by 2 by pi integral 0 to pi f of x dx. And f of x is here mod sin x, and mod sin x is always positive in the limits 0 to pi. That's why mod sin x can be taken as sin x. And evaluate the integral. You will get a0 equal to 4 by pi. Now to find an. Once observe, if in the problem, if the interval is minus pi to pi, we have chance to check whether the given function is even or odd. If you identify the given function is even, then the Fourier series contains only cosine terms, that is either both a0 and an terms. If you observe the given function is odd, then Fourier series contains only sine terms, that is only bn term. Here we observe the given function mod sin x as an even function, so its Fourier series contains only a0 and an terms. a0 we determined, that is 4 by pi. Now to find an. To find an, formula given by an equal to 2 by pi integral 0 to pi f of x cos nx dx equal to 2 by pi integral 0 to pi. Here given f of x mod sin x, but in the limits 0 to pi mod sin x is always positive, that is sin x itself. Cos nx dx. Under the integral we have two trigonometric functions, means take it as this is a sin a and cos b. 2 sin a cos b. We have formula 2 sin a cos b equal to sin of a plus b plus sin of a minus b. According to this formula, under the integral, if one of them is algebraic, another one trigonometric, we go for generalized rule of by parts. But here both are trigonometric in product. That's why the product of two trigonometric in terms of summation means like this formulas. 2 by, already we used 2 in the formula, so 1 by pi integral 0 to pi. 2 sin a cos b means sin of a plus b, sin of x plus nx plus sin of x minus nx dx. Equal to 1 by pi integral 0 to pi sin of n plus 1 of x plus sin of n minus 1 of x dx. Here 1 minus n of x, we have written here n minus 1 means taken minus sign common. So note down this as minus sign. Now after the integration, integral of sin is minus cos of n plus 1 of x by n plus 1, and here minus cos you will get minus minus plus, so cos of n minus 1 of x by n minus 1, limits 0 to pi. In the denominator we got n minus 1. It is not defined when n is equal to 1. That's why always in this step n not equal to 1, equal to 1 by pi. Now apply the limits pi. We know cos n pi equal to minus 1 whole power n. Here n plus 1. So minus 1 whole power n plus 1 by n plus 1. By applying in this term plus minus 1 whole power n minus 1 by n minus 1. Upper limit substitution, minus of lower limit. In place of x is 0, that is cos 0, 1, minus 1 by n plus 1 plus here 1 by n minus 1 equal to 1 by pi. Here one more minus sign, minus 1 whole power n plus 2. Here n plus 1 in this term also, so plus 1 by n plus 1 together if you write down. Next plus minus 1 whole power n minus 1 by here n minus 1 in the denominator, minus 1 by n minus 1. In particular n not equal to 1, this continued. This is an. Now an equal to, if n is even, we observe, if n is even and n is odd. If n is even and n is odd. If n is even, in that situation n 2, 4, 6 like that, you will get here n2 means even means here 1, that is 2 by n plus 1. If n equal to 2, it becomes odd, that is minus 2. Minus 2 by n minus 1. If you simplify this one, you will get minus 4 by pi into n square minus 1 by taking LCM and the simplification. If n is odd means n equal to 1. 1 means in the power you will get 3, that means minus 1. Minus 1 plus 1, 0. This term 0. Here also n1 means, particular n1 means it is not defined when not equal to, when n1, that is n equal to 3 onwards we have to check. If n3, you will get positive 1 here. n5 means the value becomes 1, so 1 minus 1, 0. So if n is odd, the whole value an is 0. Therefore we got an equal to minus 4 by pi n square minus 1. In particular n even and 0 if n odd. We got this when n not equal to 1. What is the value of an? In particular for n equal to 1. We have an formula 2 by pi integral 0 to pi f of x cos nx dx. That means 2 by pi 0 to pi f of x means sin x, cos nx n1, that means cos x dx. Actually we did an when n not equal to 1, because if n equal to 1, their denominator doesn't satisfy. That's why we did when n not equal to 1. Now we are finding an when n equal to 1. So when n equal to 1 means cos x. So how to evaluate this? Integral 0 to pi 2 sin a cos b, that is sin 2x dx. Integral of sin is minus cos 2x by 2, limits 0 to pi. So minus 1 by 2 pi, here cos 2x, limits 0 to pi. So minus 1 by 2 pi, Here cos 2 pi, the value is 1. And here minus cos 0, the value is 1. So A1 equal to, in particular n equal to 1, that means this is A1 equal to 0. Therefore Fourier series expansion equal to A0 by 2 plus sigma n equal to 1 to infinity an cos nx, because in the given problem Fourier series of f of x equal to mod sin x in the interval minus pi to pi. The function is even. Fourier series contains only a0 and an terms, and we got a0 equal to 4 by pi by 2, that is into by 2, and a1 equal to, you got 0, and from 2 onwards you got sigma n equal to 2 to infinity minus 4 by pi n square minus 1 cos nx. In particular n equal to even we got, and in place of odd we got values 0, so it can be written as 2 by pi plus n even. N is even, that means you have to take n 2 4 6 like that, minus 4 by pi into n square minus 1 cos nx. This is Fourier series of mod sin x in the interval minus pi to pi. Here you may write down minus 4 by pi outside of sigma also. This completes the problem.